That should be starting now. And in case anyone in attendance did not notice the kind of extra blip that I put in the description for the event, we are going to be hopefully posting these video code reviews publicly. We had some feedback from contributors that they would like some insight into the code reviewing process, and this is kind of a low effort, low time commitment way to do that. So just something to be aware of.
Okay, so thanks, Mia. This will be a video code review of MISCO's PR 1546, prepare the Constexpr machinery needed for string and vector. So some background here is that the standards committee voted in 3 papers for Constexpr containers in C++20. We very recently merged one PR from a first-time contributor, Michael Rizkala, implementing sort of centralized library support for Constexpr containers. If you look at our recent commits, you should be able to see that here. This was extensively reviewed by Mia, who has been working on reviewing sort of all these PRs in the area. And she recently created an issue tracking the state of these PRs and papers and issues and bugs, because sort of the central thing powering these papers is that we can now do Constexpr allocation and deallocation. So you can say new and delete in Constexpr mode, basically. And it also affects like the standard allocator, operator new, but different compilers have different interpretations of how it works. And of course, everybody's got bugs because it's a new feature and we're using it for the first time. So the area is pretty complicated, and it's unusual that we've got 3 features, 3 papers, all affecting this area. Usually, like, even if a feature is large, there's just like one of them. So it's sort of atomic and isolated. That's not the case here. So we've already merged the first PR that sort of stands alone, but is a building block towards the Constexpr string and Constexpr vector PRs. And so now one of our longstanding contributors, Misco, who originally started working on span and has done a whole bunch since then, a lot of ranges, has submitted PRs for Constexpr string and Constexpr vector. That's these 2, implementing the features. And so a system that we have in STL is that we track every feature with a GitHub issue, so we can add additional information, context, link things easily. So these are the corresponding issues that mention like their feature test macro. So these can be linked to the PR. We found that simply organizing the work to do in the repo has made it a lot easier for maintainers and contributors to understand what's going on. So you'll notice like all of our features were filed just as we created the repo. So most of them have low numbers for the features that were outstanding at the time we created the repo. So that's these 2. But the even after Michael Rizkala implemented the library support for Constexpr containers PR, there's still a lot of common machinery in our sort of centralized standard container implementation that needs to be Constexprized. So Misco submitted another PR, which is the one we'll be reviewing today, that will implement some of that in an effort to sort of find any MSVC and Clang bugs ahead of time, and sort of reduce the complexity that's being shared across the Constexpr string and Constexpr vector PRs. So this is kind of an exception to our usual way of working. Usually we try to merge features as a unit and not work towards them incrementally in the production code base. We certainly make exceptions for extremely large features like CareConf, ranges, things that have just taken a lot of effort to get done. In a couple other cases, we're sort of experimenting with, what if we have a long-running feature branch like feature format and feature spaceship? In this case, because it affects the shared containers, we are doing sort of incremental work in the repo. Of course, it can't destabilize the existing usage. It's sort of, it's not an ironclad rule that features have to be atomic. And so in this case, it seems to make sense that reviewing this PR will allow us to sort of reduce the complexity we have to digest. Okay, so let me go ahead and close these. A little bit more background is that we'll be seeing a lot of these macros. So in the STL, we use macros. Doesn't mean we're a fan of macros. We actually, don't like macros as much as any other programmer. But we have to support so many things like different platforms, different standard modes, differing compiler support as all of the compilers are catching up with the latest standard, that we do end up having a fair number of macros. So we've got one set of macros that tell us what standard mode we're in. And instead of having to say, if we're in C++20 mode, then use Constexpr, otherwise don't, this is so common that we have macros that expand either to Constexpr or to inline, which sort of can be put in place of Constexpr in function declarations and definitions. So if you see underscore capital Constexpr 20, this just means that this is Constexpr in C++20 mode and is just plain old inline in non-20 mode. More recently, we got another macro, Constexpr 20 dynamic. So here, after we decide whether we're going to enable this new library feature, this is the standard feature test macro cpplib Constexpr dynamic alloc. We determine whether to define this based on, are we in C++20 mode? And then is the compiler that we're being compiled by sufficiently far along that it supports this? So right now we enable cpplib Constexpr dynamic alloc only for Clang, because Clang and MSVC are our first-class citizens for CodeGen. And we will enable library features for the first one that implements the necessary support that we have. Sometimes that's MSVC, sometimes that's Clang. In this case, Clang is the first one to support this enough, but MSVC is coming along, and we expect in 16.9 preview 3, which is coming very soon, that it will have fixed enough bugs that we'll be able to enable it for MSVC as well. And then we'll have to think about, okay, does EDG IntelliSense support this? We think it does, because we support so many front ends. So when we detect that Constexpr 20 dynamic allocation is available, that's what this macro is for. This expands to Constexpr, otherwise inline. Once all of our supported compilers support this feature of CS+20, this will simply collapse into plain old Constexpr 20. We'll always have that macro as long as we support 14, 17, and 20 modes distinctly. But this extra dynamic bit is temporary, or what we call transition. It's sort of a short-lived state that will go away in the future. Previously, the precedent for this, because we're big on precedent in the STL, is we had a macro Constexpr 20 ICE for when compilers were still implementing the amazing feature is constant evaluated. And then once that became available across all compilers, we were able to smash that macro together with just plain old Constexpr 20 for simplicity. So that's our central internal header YVLS core H. So here's the PR we'll be looking at. Only 2 files changed, only 281 lines. And one cool thing is that another of our longstanding contributors, Adam Busior, has already gone through the PR and submitted review comments. And we love when this happens. Having contributors review each other's code as they learn more about the code base, this is awesome. So I've sort of quickly scanned through these comments, but we'll be reading them as we go through the files chain. So I thought we would just jump right in. If anyone has any questions, feel free to jump in. I can't see the chat right now, so just speak up.
Can I jump in super quick?
Sure.
If you jump back to the conversation tab, actually, Misco is proposing adding yet another macro, which I responded to, and I think it does make sense, but I'd love your input on this as well.
Okay. Let's see. So Misco says, I believe we need a new define. Once the next preview is out, we want to switch this around and activate all the machinery from MSVC only due to the Clang bug that prevents construction of mutable subobjects during constant evaluations. We've had to get this feature working while dealing with our non-standard but very useful iterator debugging feature that wants to transform apparently const operations into modifying operations. So that's where some of that complexity comes from. And so Misco is saying he wants to switch it around, okay, and activate it for MSVC and not Clang, but not disrupt the stuff we just implemented, which will still work for Clang, if I understand that correctly.
Yeah,
So
that's
he
why I
proposes,
understand.
okay. So he proposes Constexpr 20 container, and then Mia replies, we should be unblocked to implement Constexpr string infector. Okay, yes, that sounds right. Yeah. And then we've got the Clang bug, LVM 48606. Okay, and then here we want to actually, yeah, check the compiler. And yeah, we don't want to go backwards because we just worked so hard getting all of this, the feature that Mike Brascala implemented working. And if we turn off test support for it, it could regress due to library changes that we do, or in theory, compiler changes. So yes, this all sounds right to me. I agree. Having a Constexpr 20 container seems reasonable. That's appropriately neutral between string and vector. It's not too long, and it will eventually smash into 20. And also avoid saying like Constexpr 20, except Clang is buggy. It just says, hey, do you have support for the Constexpr containers? So I will give these a thumbs up. Okay.
Awesome. Thank you.
Sure. Thanks for bringing that to my attention. Okay, so let's look at the files. So here, the trick that I learned from Casey is if you alt-click on the little chevron, you can collapse all of them. So these are two changes to our internal headers. We currently use the convention that any header beginning with X is internal. So X memory, X utility, these are internal headers. Minor changes in X utility, and then major changes in X memory. And I think I already turned on, oh no, let's turn on hide white space changes because this helps a little bit. Okay. So I'm going to look at X utility first just because it is smaller. Okay, so changes to construct in place. So one of the things that we do when reviewing features is that we'll often have the standards for the feature open in split screen or on another monitor, and then just go through the PR, compare it to the paper, and make sure that every change to the standard mentioned in the paper is in the PR, that all of the changes in the PR are motivated in some way by changes in the paper, and that we don't have changes missing or added unnecessarily. And because standard proposals can be modified later by LWG issue resolutions, library working group issue resolutions, and further papers, or even just editorial changes. The true source of authority is the working draft itself, currently N4878. So ideally, we compare against that. But the proposal has voted it as a useful guide to what changed in the feature. In this case, because it's common machinery for the Constexpr containers, this, and it's all sort of our internal machinery. I'm not comparing it against the proposal. This will be stuff, the changes to the common, I think, iterator debugging, or some of our REI helpers, allocation helpers. So eventually this will be reflected in the two proposals for Constexpr string and vector, but doesn't directly map to many of them. But if I do see any non-ugly functions being modified, functions that are visible to the user, we may want to go open those papers and make sure that the interface conforms and so forth. So here's our helper to construct an object in place. This is sort of obnoxious enough that we've now centralized it into a single function because we have to handle perfect forwarding and constant evaluation and so forth. So here this is being marked as Constexpr 20 dynamic. Okay, and then the rest of the signatures unchanged. We're wrapping this no except thanks to Clang format. So that's great. And so the code that's being added is if the cplib is constant evaluated features available, which this is, by the way, this is now synonymous with if has CXX20. So if we're in CS20 mode. But for clarity, we're continuing to just use the feature test macro when we're specifically looking for this availability. So if std is constant evaluated, then we're going to construct at the address of the object from forwarded arguments. Okay. because, as I understand it, when we're in Constexpr mode, construct_at is enlightened according to the standard to work, even though true placement new doesn't necessarily work, if I understand that correctly. I know there's some divergence between MSVC and Clang, but this path, because it's not conditional on compiler, should work for both of them. Otherwise, I believe the idea here is that why pay the extra debug code gen to go through construct_at? We can just directly call true placement new. So otherwise, we use the existing code path. Okay, so this looks correct to me. And then we have a helper right below, default construct in place, that just says, okay, so this is interesting. So I don't immediately understand why this can use true placement new. The interesting thing here is that because it's a default construct, we're trying not to say any parentheses, otherwise that would give us value initialization. So that's why we can't use construct_at. But if this works for default construction, then why doesn't this work for value in it, when there's no args, there's actual args? I don't actually understand why this is necessary. Just from the code that's here.
I
So
actually had a similar question in this particular case. I think like we have green tests right now because Constexpr 20 dynamic is only Constexpr for Clang, and Clang generally allows placement new if it is reached through a call to allocate.
Okay.
But when this flips on for MSVC, as far as I know, I don't know that this will continue to work.
Okay, specifically that the default construct in place might not work?
Yeah, I actually have a pending comment essentially asking the same question.
Oh, okay.
So yeah, unless Cameron has some special knowledge here that I'm misunderstanding, or go Cameron.
Yeah, I mean, it really comes down to which function ends up being called. So MSVC will outright reject the default construct in place because placement new is not Constexpr.
Right.
So if that function ends up being called in any capacity in a Constexpr context, we'll reject it outright. I suspect that there's probably some branch that says, hey, if we're in Constexpr land, we're just always going to use std construct_at because that's always Constexprable. But I'm not exactly sure.
So it looks like we have one occurrence in the STL, and it makes me very happy when the search finds not the latest version. Here we go. So it's the std uninitialized default construct that calls this. So that's interesting because, as far as I know, basic string and vector do not use this. Vector can't use this because it doesn't take the allocator. We have like helpers that are ugly and take allocators for the uninitialized helpers. And string, as far as I know, never wants to uninitialize default construct a character. Why would you have a garbage character? That doesn't help. So I'm pretty sure we don't actually need to mark that as Constexpr 20 dynamic. Let me see if anybody calls this. If I had my repo on this machine, then it would be easier. I wouldn't have to use GitHub search. Okay, so we've got a test there. We implemented memory, and then we test it. So actually, this is a leaf function. We never call this in the STL itself. Okay, so I think that Mia's pending comment is correct. And also, this should probably just not be marked Constexpr 20 dynamic at all. Because it looks like it's not actually required by anything, if I understand this correctly. Okay, Mia, do you want to edit your pending comment about that, or should I comment this here? It doesn't make sense for us to both have comments.
Yeah, you go ahead and do it. I glanced through this enough to just look at that and make a comment, and haven't really resumed my review since then. So you go ahead and comment on that. I am looking through the actual repo that I have on my machine, and yeah, all I see is references in memory that all look in some way related to uninitialized default construct. So
Okay.
if it turns out for some strange reason we do actually need that to be Constexpr 20 dynamic, one, we would need to make sure this is not going to be on an MSVC code path, and two, we could potentially treat it as we did for, I think, some other cases in the Constexpr allocator traits where we only Constexpr 20 dynamic for Clang, so that it'll flip on correctly even when we have support for both compilers.
Okay, yeah, that sounds right. Okay, so I'll add a comment. It appears that this will not compile for MSVC when Constexpr 20 dynalic is activated for it. However, but it additionally appears that this function isn't called by basic string and vector. I should have kept the tab open where I actually found the call.
Cameron, do you still have your hand up from before, or did you want to mention something else?
I wanted to mention something else, which is that construct@at can't actually give you the same semantics as what this default initialization function is giving you. So there's no way to there's no way to like construct in place a default initialized object. You'll always get value initialization.
Yeah, because you would get empty parentheses. Yep. Okay, let me see if I can find that function. My machine is doing the wonderful thing where it starts overheating. Come on. It's right there. I know it's there. Okay, I'm going to give up on citing the exact function. It appears to be called by a single function which isn't called by anything else in the STL. I believe that Constexpr 20 dynamic should simply be dropped here unless it's necessary for a reason that I don't see. Okay. It appears that this will not compile for MSVC when Constexpr 20 dynamic is active for it, but it additionally appears that this function isn't called by basic string and vector. It appears to be called by a single function which isn't called by anything else in the STL. I believe that Constexpr 20 dynamic should simply be dropped here unless it's necessary for a reason I don't see. Okay.
Just to clarify, it does look like it's called in more than one function. They just look like they're all related to specifically uninitialized default construct.
Okay. So
there's only one pretty function. The others are all helper functions, it looks like.
Oh, okay. Interesting. GitHub search was not turning that up for me. So
GitHub search rarely turns up the right thing.
Yes. Let me edit this. I'll just drop this bit because we don't believe that basic string and vector. Okay.
Can that be basic string or vector? It isn't called by either.
Yeah, that sounds good. Review the code review comment. It appears that this will not compile for MSVC when Constexpr dynamic is active here. Additionally, appears that this function is called by base string or vector. Dynamic should be simply dropped here unless necessary for resiliency. Okay. Great. Okay, but this looks right, which is good. And then this I'm assuming, based on what Cameron just explained, is essentially it's a sort of a throughput optimization, if I understand it. No, this is necessary for MSVC. If for MSVC, then we got to go through construct add in Constexpr mode. But if we're not in Constexpr mode, no reason to go through an extra layer, just directly call placement new, because that's fine. And then Clang would accept this, but it's okay to send it through construct add as well. Okay, so it's not actually throughput optimization. It's just this is what's required for MSVC, and it happens to work for Clang too, because it's the technically standard way to do it. Okay. So viewed, 50% done. Awesome. Okay, let's open this up. Come on. Let me see if I can turn off my outgoing video and see if that helps my machine. Probably my incoming video as well. Okay. Okay, let's load memory. There we go. Yeah, this is makes reviewing somewhat difficult. I have a new fast desktop PC, but it doesn't have a webcam. Okay, so in Xmemory, we now use RAII helpers, which we call guards, to call our member functions called tidy that typically deallocate everything owned by a container and reset its data members. And we used to have try-catch logic for many years. We switched to RAII because it actually improves debugging to not rethrow the exception. And it's sort of neutral for CodeGen on x86. It's basically the same either way, as I understand it. And for x64, I believe it can actually improve CodeGen because we sorry, no, it's neutral for CodeGen too, because we always execute the destructor. That actually may improve CodeGen slightly. I'm sort of mentally running the CodeGen in my head. I'm like, oh, we usually dismiss the guard, and this actually only activates when an exception is thrown. So here, because we need this user-defined destructor, but various vector and string member functions will now have to be Constexpr dynamic, then the user-defined destructor needs to be marked as Constexpr 20 dynamic as well. So that's why this is being marked. Similarly for the tidy deallocate guard, yep. Okay, global new. This is a helper that also has an internal guard. This will call new and not be hijacked by user overloads. So the function itself is now being marked as Constexpr 20 dynamic. Okay. I see a pre-existing issue. This really should probably be no discard, but I will refrain from commenting on that because it is pre-existing. Okay, and then this DDoR is also Constexpr 20 dynamic. Yep, that looks good. Okay. Scroll down. Come on.
Stefan?
Yep.
Looks like on line 279, there's another placement new in
true. Yeah, that's right. This is true placement new. So you're thinking that would be an error for MSVC.
Yeah, that's just red flags.
Yeah, interesting. Yeah, great catch. So that should really be ideally an if-def or the same sort of, probably the same pattern as we saw in constructed place. In fact, why aren't we using that here? Aside from debug throughput, we could simply call that helper function in from xutility and get that centralized.
Yeah, instead of having the repeated if def cpp lib, like if constant evaluated and all of that.
Yeah, we would still have extra layers of forwards, which really should be immediately optimized away by the front end, but it would simplify the code. I'll add a comment. That was what, construct in place? Can I collapse
yes.
this? Okay.
Underscore capital construct in place. I don't want to make you toggle your files open
Yeah.
and close too often.
Like, no, too late. Okay, let me copy this. Switch over. Okay, I'm gonna have to comment on this line. Okay. Lines below, there's a direct call to true placement new. This is my unofficial term for saying :new, and then give it a void star, and then the type and any arguments to distinguish it from other kinds of new, which we believe will be an error for MSVC. Should it be changed to call construct in place, which will work for all compilers? Okay, good. Awesome. Thanks, Mia. Okay, continuing on, we got Refancy. This is where we deal with mapping from raw pointers to potential fancy pointers provided by an allocator that could do weird things like shared memory, or who knows what fancy pointers do. So this is just being marked as plain Constexpr 20 because it doesn't directly involve dynamic allocation. That seems fine. And pointer traits pointer 2 was separately Constexpr-fied in, I want to say, by an LWG issue. We did this a while ago. Maybe it was part of another paper. I'd have to go look it up. This seems fine. I don't think it needs to be Constexpr 20 dynamic, and they'll collapse together in the future anyways. And then if we have a raw pointer, then you just return unchanged. That can be Constexpr 20, so that's good. So this is a member function of a std allocator. Okay. Yeah, this is std allocator itself. So its construct. So this was deprecated in 17. It's removed in 20. I think, but we have not yet implemented that removal. I think we have, do we have an issue to implement that removal?
We do. It's linked somewhere in the Constexpr allocator traits. I think Adam Busio, or was it someone else who discovered that?
That sounds right. Okay, so this really should be wrapped eventually in if and def, or if def has this feature, and then that will be turned off for CS plus 20. So we're not going and marking these as Constexpr because that would be going beyond the standard. These things aren't even supposed to exist in 20 mode. We allow them to be activated, or will allow them to be activated by an escape hatch, but we're not going to go beyond the standard and say that they're Constexpr. It does appear that MISCO has a cleanup or consistency improvement to call our helper voidify iter that takes a raw pointer and then converts it into void star, doing this casting dance. If I understand it correctly, this is not needed for the Constexpr centralization. It's simply a drive-by cleanup. I think that's okay, because we do call voidify iter everywhere else like this. Okay. Then we have our helpers that Really, at this point, we could probably just lift, now that we can use if Constexpr unconditionally, we could probably lift them up directly. But having these helper functions is maybe a little more convenient. We will need to call these from the containers when they're doing things like copy assignment and so forth. This stands for propagate on container copy assignment, move assignment, and swap. So the arcane pronunciations poka, pokma, pokes. And these are being marked as Constexpr 20 because they don't directly involve dynamic allocation. That seems fine. And then the allocator itself will need to be Constexpr assignable if somebody wants to do that. Okay, so that's Constexpr 20. I believe we've already marked swap ADL as Constexpr at some point. That would be in Xutility. Do I dare do a search? Come on.
I'm looking in the repo right now. I don't actually see any results coming up in Xutility. Would it be in utility maybe?
Yeah, it's utility. And it is
yeah,
already,
that's already
yeah, Constexpr 20. Okay, so that's good. Okay, otherwise I still cert. Okay, that's great. Helper to destroy a range of stuff, optimization for debug mode. It's being marked as Constexpr 20 dynamic because we need to destroy stuff. That seems right. Wrap by Clang format, fit in 120 columns. That looks good. Just looking at how we're destroying. Okay, we go through the allocator traits. Okay. Deallocate plane. This will deallocate a plane pointer. Also marked as Constexpr 20 dynamic. Okay, deallocate pointer. These are already Constexpr. Delete, used for internal container types. Okay. Also Constexpr 20 dynamic. Yep. Okay, we've got an RII guard, alloc construct putter. So this is okay. So if I understand it correctly, doesn't this constructor need to be Constexpr if we want to have a hope of using this in constant evaluation? Because if the destructor needs to be Constexpr, why isn't the constructor as well? That seems like a missing annotation. In fact, I'm not even sure it would compile, because if it's not marked Constexpr, there's nothing stopping us from putting like a printf call in that constructor. So I think that is missing there. I will add a comment. Is this constructor missing Constexpr 20 dynamic? Okay. Yeah, and it can't just be defaulted because we actually need to store a reference to the allocator. Okay, but when we release, we are using std exchange to, excuse me, swap in null putter and then return the old pointer. So that's Constexpr 20 dynamic. Allocate calls, allocate the DDOR, deallocates if it's not null. Okay, that looks good. Excuse me, talking too much. Okay. So we've got container container base here. These were being marked as Constexpr 20. And Adam Busior is suggesting plain Constexpr, or and then Misco says they can't. Excuse me. And why is that? Problem is that we're invoking undefined behavior in the iterator machinery. Oh yes, because we don't have the mutable data members. And it's being prevented from a Clang because of a Clang bug. So I wonder if this should be marked as transition. So one of the things we do for sort of long-term code-based health is when we see something that's not right or not ideal and we want to change it, we'll mark it ideally in the source code with a comment, all capital transition, and then we'll either cite a bug or explain what's wrong and how it ideally how it needs to be changed in the future, because the code is very long-lived, and tagging it will allow it to remain in the same in the right place even as code is moved around. So sometimes we'll file an enhancement issue or something, but code comments are sort of a good way to remember. In this case, I wonder if this is worth a transition comment. It seems like probably not. I think Constexpr 20 is fine because it's not a big change in like code complexity, and in 14 and 17 mode, we do not need Constexpr containers. So I think having this be permanently Constexpr 20 is fine. I don't think we need a transition comment. Okay. Iterator base, Adam had the same comment here. So let me actually look at these. So these are the definitions of do nothing. So some background here. For those who have not had the fortune to not study iterator debugging in detail over many years, this is our complicated feature that still provides a lot of user value. So that's why we sort of suffer through continuing to maintain it. And the idea is that in release mode, we set a macro called iterator debug level to 0. And this means maximum efficiency, no checking. The only sort of checking we do is for integer overflow when allocating, because that's so dangerous and so cheap to check. But no iterator validity checking or anything like that. In debug mode, though, because of issues like iterator invalidation, where if somebody's not careful, they can get an iterator to a container and then resize their vector or something with a pushback or whatever, and invalidate the iterator they thought they had pointing to the container's guts. We have an elaborate system of bookkeeping that allows iterators to find their parent containers. There's something we call the proxy object, and allows the parent container to notify all of its children or some of its children when all or part of the container is being reallocated or assigned to, and the iterators there are being invalidated. And so our machinery for this is partially centralized in base classes called container base. In this case, container base 0 is the base class used when we have no iterator debugging. So that's why these functions exist and they don't do anything. So if we're told to disconnect our children iterators through the member function orphanal, we just do nothing because we don't have any children. So this still needs to be Constexpr to be called from a Constexpr function. So that's why these are being marked. So that's all good. Same with the base class for all iterators. To attach it to parent container or get the parent container, these functions will become Constexpr 20. Okay. And then here, this is the container proxy and container base 1.2. These are used by iterator debugging when it's actually active. So the proxy is one of the most complicated parts of our implementation. And it's something that we're actually going to remove in the next binary breaking release of our library. We have pending changes that are stranded in TFS, Teams Foundation Server, that we'll need to port to Git when we finish CS+20. The proxy is a dynamically allocated object that allows us to swap containers or move containers and preserve all of their children iterators without invalidating them, because swaps for like vector are supposed to be constant time, iterator preserving, and no fail. Unfortunately, allocating the proxy has a set of undesirable consequences, which is why we're getting rid of it in vNext. So here, Misco is marking my first iter as mutable, which we believe can be done without breaking ABI, because it doesn't actually affect the layout of bits in the container. Then he's providing data member initializers, setting these to null putter. And then that allows us to provide a defaulted definition for the constructor and mark it as Constexpr 20. So this is like an efficiency or sort of a simplicity change there. That seems fine. And then if we're being given a parent pointer, and for some reason we never bothered marking this as explicit, it doesn't really matter because it's going to be removed from vnext. We store that in the proxy, and then this becomes Cont Expert. So that's okay. And then we don't need to initialize that to null putter. Okay, so this is all good. One thing that we're trying to look out for is, surprisingly, changing an implemented copy constructor to a defaulted definition can be an ABI break. I encountered this in std-tuple, where I broke ABI a few years ago and had to go fix it up. So that change is scary when it's a copy constructor, but for a default constructor, it's fine. That does not affect ABI. In fact, we recently double-checked this when tuple was cleaned up. So I'm fine with that. And then container base 1.2 is the base of all containers. Here it looks like, yep, the proxy pointer is now being given a data member initializer of null putter. Okay. And then that can default this default constructor. Okay, that's good. Make it Constexpr 20 dynamic. And Mbusi is suggesting Constexpr, but that may not be possible because of the Clang issue and is not critical. So I'll let Misko respond to that. Deleted copy and assign. Orphanol will be dynamic. Same with swap proxy. Alloc proxy goes through the allocator. Okay, so this definition is all good. Reload proxy. Okay, yep, all functions that are either already Constexpr or being changed to be, so that can be Constexpr 20 dynamic. And then he's adding new helper functions, I believe, to deal with the issue of if we're in Constexpr mode, we can't go through certain code paths. The workaround we have is have member functions that can be called in one branch or the other. So orphan all, oh yes, it's the fact that we need to take a debug lock, and we can't even construct that in a non-taken branch of Constexpr evaluation, which probably should be fixed in the core language, but that fix hasn't happened yet. So currently we need this workaround. Yep, and these have to be inline because they're being defined out of line. Okay. So iterator base 1.2. Okay, double checking. Interesting that this unnecessary public was already here and then we never had a private section, but now it seems reasonable, even though it is a struct, to have public and private. Okay, it's pre-existing. I'm not going to refrain from making cleanup comments in pre-existing code. And then here, adding the public is consistent with what's above, so I'll accept it. Okay, so we've got iterator base 1.2, which is the base class of all iterators. That we have this interesting singly linked chain of iterators that is intrusive. So to avoid allocating something in each iterator has a pointer to the next iterator, where the order is just sort of like construction order. It doesn't really matter. It may actually be reverse construction order because it's a singly linked list. In vnext, we're changing that to be a doubly linked list.
Hey, Stefan, can you move your mouse? Because it looks like we might have video frozen, at least on our end.
I just I'm moving my mouse. I'm moving the window.
No.
Unmaximizing it. Is it frozen?
Yeah, it looks like it's frozen.
Let me see if I stop presenting will help. What's funny is my machine is actually responding right now. It's no longer being a slideshow. Just can't win. Okay, I stopped presenting. Did that do anything?
Now I see just our pile of profile pictures or.
Okay, let me try sharing again, see if that helps. I'm sharing again. Are we back?
It looks great. I see moving mice and I see you are working on maximizing your window.
Okay, excellent. Okay. So we are reviewing struct iterator base 1.2. It is now having public and presumably private sections. Wow, this is getting quite complicated. Here it is. My proxy, my extender, these have equal null putter, data member initializers. Yep, there's the private section. Okay. So let's go back up. This is where the most of the fun is happening in this review, it looks like. Oh, I went too far. That's container base 1.2. Is very base 1.2. Okay. So the default constructor, because it now has data member initializers, it can now be defaulted, and they'll provide the null putters, and it will be Constexpr 20 dynamic. Yep, that looks good. Same sort of comment from Adam Bussior. The copy constructor, copy constructor. It previously was initializing my proxy, my extender, null putter before doing a copy assignment. Now that's no longer necessary because they will be initialized by the DMIs. And this is not being defaulted, so no ABI breaks. That's good. Okay. Copy assignment operator can be Constexpr 20 dynamic. Okay, so here is the change that's happening where it looks like Misco is moving the lock into orphan me. So the thing that immediately occurs to me is because, and this doesn't appear in the code at all, but this is changing the semantics of orphan me. Previously, orphan me did not take a lock itself. It expected to have the debug lock held while it was called. This is necessary because in iterator debugging, we're making constant operations. Like you can have a container, you can construct iterator, you can call like .begin on it to get iterators, go use those iterators and then destroy the iterators. And the container itself can be const. You can do that through a const reference. But what we're doing is we're actually modifying the container's my first iter pointer so that it knows where its child iterators are. And because calling like .begin is const, we can call begin on a single container from multiple threads simultaneously. But if we've secretly made that physically modifying, then that's data race. We can't have that. So we need to take a lock in order to restore the usual thread safety guarantee. So that's why we've got this debug lock here. But because disconstructing that locket is forbidden in Constexpr mode, we need to have this these separate code paths to detect if we're in constant evaluation mode. And if we are, then don't bother taking the lock because there's no threads. But if we aren't, if we're at runtime, we do need to take the lock. So that's all fine, except that we're changing the semantics of orphan me. And this, I believe, raises the potential for essentially a ABI break or a bin compat issue, a mix and match issue, where if we have separate translation units that are being compiled in by different builds of the STL, one before this change and one after, one translation unit after could expect, okay, orphan me will take the lock. Like if a translation unit has a definition of this operator equal with this PR, it could not even 20 mode, because this change is being done unconditionally. It would call orphan me and expect, hey, you're going to take the lock. But what if orphan me is provided and chosen by the linker from a translation unit that was compiled before this change? Then orphan me would be expecting the caller to take the lock, and it wouldn't take any lock at all. And if we end up in this mixed compiler situation with the linker picking different definitions, which could happen, we wouldn't end up taking a lock at all. And then debug mode would crash. That would be bad. So this appears to be a bin compat issue or mix and match issue because the semantics of a function are being changed without naming the function. Now we do have a way to fix this. We have found over the years as we've thought through these issues, and we've had to add and make so many changes while preserving bin compat, is that even though technically modifying anything in a header is an ODR violation, we violate the one definition rule as soon as we change any header-only implementation, because if you mix and match different compiled translation units, there's no longer one definition, there's the before and the after the definition. But some ODR violations are innocuous, and some are potentially lethal. In this case, this is one of the bad ones. So I believe the fix is that we need to rename this member function. If we rename it, it's fine, because even if the linker is, sort of maximally hostile to us and picking definitions seemingly at random, if it has a definition of the original name orphan me, that one will expect the lock to be held. If it has a definition of orphan me v2 or whatever we call it, that one will take the lock itself, and then whichever definition of operator equal is compiled, it will find the right definition of orphan me or orphan me v2. And this is necessary. So typically this happens whenever we make coordinated changes to functions. In this case, the change is happening between operator equal and orphan me. So we need to rename this one. So I will add a comment here. And now I'm thinking, have we done this before accidentally? And I hope we haven't. I'll maybe mention that, but certainly we should not do it in the future. Okay, there appears to be an ABI mix and match issue here. The problem is that orphan me's semantics are being changed. Previously, it expected the debug lock to be held, and now it is responsible for acquiring the debug lock. Okay, so what's the situation here? It's if iterator base 1.2 operator equals new definition, which doesn't require the lock, is mixed with orphan me old definition, which didn't require the lock. Doom results. There will be doom. Believe we can avoid this by renaming orphan me, so that if the old name is required by the, or old name is that if the linker looks for the old name, it will find the old definition. And similarly for the new name and new definition. Operator equal will have a varying definition, but that's okay, because whichever version is selected, it will provide the same observable behavior. We have to think real hard about like mixing and matching, because ultimately when it comes to ODR violations and how severe they are and whether we're going to break ABI, we have to think about like all the possible combinations of old compilers, new compilers, old standard mode, new standard mode, before the PR, after the PR, and so forth. Because nothing actually enforces that we get it right. And so far, by just thinking hard, we have almost completely avoided breaking ABI. There's only like 2 occurrences where we've accidentally done something, we've fixed them up. It will provide the same observable behavior. Then the question is, do we need to zombify the name? We have this a test that ensures that when we need to make this sort of renaming change to top level functions, that we don't reuse those names. This has happened for classes implementing make shared and so forth. In this case, it's a member function. So I don't think we need to try to zombify that name and make sure we don't reuse it. Because if we ever went back and changed this to plain old Orphan Me, we'd be back at the same problem. I'll say no strong opinions on the new name. Could use a v2 suffix or name it or something else. Let's go choose. Okay. Expect the debug lock to be held. New name, a new definition. Okay. Okay, so an apparently innocuous line being moved turns out to be a big ABI issue. That's good. That's what code review is for. That is hopefully going to save us headaches down the road. Okay, just moving a white space change. Okay with that. Okay, so now previously we used to have always the destructor, and then in IDL2 it would do something. Now the destructor is being moved entirely within IDL2. Do we have an else later? Yes. And no destructor there. Interesting. My brain is trying to run. Why do we have? Oh, it's because it's iterator base 1, 2. So this name it's not 12. It's 1, 2. This is used for iterator debug level 1, which is not really used by anybody anymore. We should probably drop support for it. We will drop support for it in vNext. It was intended to be a lightweight security feature and doesn't really achieve what it wants. Only in iterator debug level 2 do we need to disconnect iterators. Otherwise, we don't have an iterator chain. We just have a proxy. And oddly enough, as I recall, it is the derived container that actually needs to allocate the proxy. Actually, this is iterator based, doesn't allocate anything. So that's right. When destroying the iterator in iterator debug level 2, sorry for my thoughts being uninformed here, we need to disconnect the child iterator from the parent. But in iterator debug level 1, there's no action needed. We just destroy the iterator because the parent doesn't know where its children are. Okay, so that's good. So if we have the destructor, it can be Constexpr 20 dynamic. Okay, so I need to be on the lookout for any other functions whose semantics regarding locking are changing. That is true here. It's not true here because the destructor either exists or doesn't. If we rename the function, then it will, if we rename specifically Orphan Me, that will affect all the call sites. So this one will be corrected, so that's good. So we don't need to comment that again. Okay. Next, if we're in IDL2, we need to be adopted by a container that's going to be Constexpr 20 dynamic. Okay. And then comment moving up. Okay. Okay, so if the proxy pointers differ, we used to acquire a lock, call Orphan Me, that's being renamed, and then we would manually update the necessary pointers to stitch ourselves into the iterator chain. This is now being replaced by a function. So this is okay because this is replacing raw code with new named functions. So before the change, this was all self-contained. After the change, this will look for new functions. So this essentially does the renaming that we want. This is good. So no mix and match issue here. Okay, if we have constant evaluated, then if we are, call adopt unlocked because no multi-threading in Constexpr land. Otherwise, call adopt locked. Okay, that's good. Otherwise, Orphan Me, that'll be renamed. Okay, that's good. Okay. Let's implement Orphan Me. Okay. So it's going to be Constexpr 20 dynamic. If we have a proxy, then do stuff for constant evaluated. Okay, so that looks good. It's just this name needs to be changed, locked or unlocked or v2 or whatever. Okay, and then above, that was for IDL2. Below is IDL not to. Okay. We've got these preprocessor comments to help us keep clear, which region we're in. Very useful. One of the things I like working about in the like about working in the STL. Okay, so if we are iterator base 1, 2, but IDL is not 2, that means we're really IDL 1. Adopt will be Constexpr 20 dynamic. If we are being given a parent, we just point to it, but the parent has no iterator change, so nothing to modify the other way. Otherwise, null it out. Okay, that's good. No mix and match issues there. Get container is Constexpr 20 dynamic. Yep. We've got this static Constexpr bool. Okay, that's IDL 0. There's the data members. Okay, we're out of the preprocessor region, then we go back in. If we're in IDL 2 mode, now we have private helper member functions that are helpers. Adopt unlock is Constexpr 20 dynamic. Okay. If we're being given a proxy, then disconnect anything that we currently have. Okay, and we're already being told no lock. Okay, and then do the manual surgery needed. Okay, adopt lock takes the lock. Okay, that's fine. We're still within a class, so inline is implicit. Okay. Let's see, these are taking container proxy. We have not really been disciplined about marking pointers as top level const in the existing code, so no reason to be obsessive about that in the new code, so I'm okay with that. Okay, so we are in adopt locked. Okay, and then orphan unlocked, Constexpr 20 dynamic. No change there. Orphan locked takes the lock. Okay, good. Okay. Woo. Now we are implementing container-based 12 member functions now that we've got iterator base 1, 2 defined. So this will be Constexpr 20 dynamic. Okay. I'm not super happy that these empty lines are being removed. I thought they added clarity, but I won't complain too much. Orphan all locked. We'll take the lock. Okay, that's good. Orphan all is this one that needs to change. Be renamed for mix and match issues. I'm thinking yes. Interesting. The previous semantics of orphan me were unlocked. We essentially assumed that the lock was being held. So this name conflict could actually be resolved by by making the unlocked one just plain orphan me, and the one that maybe needs to take a lock, call it orphan me locked, and then change this call. And that would avoid having to. It could be either way. Oh no, we would still need a third function to decide whether to take the lock. So it's sort of unavoidable to have 3 functions in the new implementation. It's just we could avoid having 3 different names, and we could reuse one name, but then that's not really clear. So okay. Okay, so orphan all. Do we have the same issue? I want to look for the calls that don't provide any args. Okay, container base 0. Who's calling this? Oh, the calls are happening in containers, not within here, like vector. Okay, so what is going on here? What did orphan all used to do? Orphan all used to take the lock itself. Okay, so orphan all was not expecting. Okay, I like what Misco is doing with the naming here, marking things as unlocked or locked. Previously, there was this sort of confusing difference between orphan me, which expected the lock to be held, and orphan all in the container that would take the lock itself. That's weird. So now they're becoming, are they becoming consistent? Orphan me is now responsible for taking the lock and will either, yeah, lock or not. Yeah. And then orphan, so it's now becoming like orphan all. Okay, so it's actually a consistency improvement. That's really good. And it's not just like, superficial naming, it's actually the semantics. Okay, so orphan all, the semantics are not changing. It used to always take the lock. Now it conditionally takes the lock depending on whether we're Const Expert. So there is no mix and match issue here. Even if an old definition was calling this will do the right thing. And then a new TU that selects an old implementation that unconditionally takes the lock is also okay because it can't be Const Expert. Const Expert all happens within the single TU. So if we at runtime get the old definition, mob is taking the lock anyways. So it's as if this were returning false. So that's actually okay. There's no mix and match issue there. Good. Okay, that was a lot to think about. Okay, so where was I? We were looking at orphan all. Okay, so we were, wait, did I scroll down too much? Here's the first definition. Okay, those are declarations. Okay, I was about here. Okay. So Constexpr 20 dynamic, orphan all unlocked. Okay, yep, nuking that empty line. Okay, now orphan all locked. Takes the lock and then calls it. Okay. This could really probably be defined inline because it doesn't in fact, yeah, there's no reason. Okay, fine. We keep the definitions together. We've got this convention or sort of preference in the STL that we'll do out of class definitions only when we absolutely have to. We prefer to just put everything in the class definition when possible. That could be the case for orphan all locked. I will suggest it because it is true that conventionally we try to avoid this. I believe this could simply be defined within the container base 1.2 class definition, as it doesn't directly mention iterator base 1.2 machinery. We conventionally avoid out of line member function definitions, except when they are absolutely necessary. Okay. I think that occurs again for one other, we'll see about that. That's probably this one. Nope, no, that one was in line. This is the first out of line one. Okay. Okay, so now we got orphan all, which is Constexpr 20 dynamic. Okay, let's move down basically. Yeah, if we have a proxy, this is what we looked at. Okay, orphan all locked. Okay, I think that's good. Swap proxy and iterator is unlocked. Okay. Okay, so for swap proxy and iterators, do we have a renaming issue? Previously, it always acquired the lock in IDL2 mode. Now it determines whether it needs to acquire the lock. So just like orphan all, its semantics are not changing. So it really was specific to orphan me. Okay, good. Take the lock. This is the one that I think could also be in line. Could be defined within the class definition. Okay. Yeah, the presence of sort of inline here is the signal. Cont Expert 20 dynamic. Okay, so if IDL not to, just call unlocked. No reason to take a lock because we're not updating a chain. Otherwise, okay, stylistic nitpick. We've got a negated test here. We conventionally prefer to avoid negated tests. This is true for both plain old ifs at runtime or if Const Expert and for preprocessor checks. The idea being that it's simpler to see if positive statement, else what if that doesn't hold, rather than if negative statement, and then the else is the positive case. So it's not a major issue, but I will mention it. We conventionally prefer to avoid negated tests when doing so doesn't negated tests unless there's a code clarity reason. Here, swapping or the test to be IDL2 would avoid the negation in not equal. This avoids mental double negatives. That's a good reason. We conventionally prefer to avoid negated tests unless there's a code clarity reason. This avoids mental double negatives. Here, changing the test to be IDL equals 2 would avoid the negation in not equal. Let's say, and swapping the blocks. Okay. Okay, so if we are IDL2, do this, maybe take a lock, otherwise don't. Okay. I'm sort of mentally thinking, we probably could fuse these. We could say something like, if for IDL2 and CPB lib is constant evaluated, is available, and we are not constant evaluated, then call the lock function and return. But that's a lot of surgery. I don't think that really improves clarity. I think this is fine. Okay. Okay, so that's the end of container-based. Now we're up to fake proxy putter impl. What do we even have this for? This was added at some point, so it's not in my brain. Proxy smart pointer. Wow, I have not modified this machinery in ages or ever, so I'm not familiar with this. Wow. I sort of remember the, no, I didn't want to click on that. I sort of remember the original classic implementation of all this proxy stuff when I first worked on it, and then the new implementation I've got in vNext, and this was added during maintenance, and I am not familiar with it, so I'm sort of refreshing myself. We've got, this looks like RII tech, interesting. Okay, so I'm not 100% up to speed on this, but let's review it. So these constructors are being marked as Const Expert 20 dynamic. Okay. Bind and release. Okay. When we just null out the pointer, that can be unconditionally Constexpr. That seems fine. Okay. Container proxy putter 1.2. Detaching the comment, that's fine. Mark it Constexpr 20 dynamic. Okay. This is, oh, the comment's being detached, which is why this can move up. Okay. Being marked as Constexpr 20 dynamic. Yep. Okay, so that all seems fine. I don't see anything missing on the functions here. DDoR is now Constexpr 20 dynamic. Delete plain internal. Okay. Okay, so now we're on to our RAI guards for uninitialized construction. This will, as we are constructing elements, if an exception is thrown, we need to destroy what we've constructed so far. We used to have try-catch logic for this, and centralizing it into the guard actually improved clarity in addition to getting rid of that rethrow. Okay, so the constructors here were just unconditionally Constexpr, so no issue like we found with the other one. Now the DDoR will be Constexpr 20 dynamic because that paper allowed destructors to be Constexpr, I believe. Place back dynamic, okay. Release is just assigning, so that can be Constexpr, okay. Good. Uninitialized move unchecked. Being marked as Constexpr 20 dynamic, that's wrapping. Okay, if we could engage the putter move cat really trivial optimization, then if is constant values available, and in that case, if we're not constant value, we need to guard this. Okay, and we do have braces. Always love those braces on control flow. Then do the copy mem move optimization. Okay, that looks good. Okay, oh, that's because I'm ignoring white space. That's why that looks weird. Okay, and then uninitialized back out with an allocator is now Constexpr 20 dynamic. Okay. DDoR is well. And place back is release. Okay. Uninitialized copy algorithm taking an allocator is Constexpr 20 dynamic. Okay. Called internally. This is for vector. What's funny is that you've got these containers in the STL that are templatized on potentially user-defined allocators. You've got all these uninitialized sort of special memory algorithms, but they don't take allocators, and that's exactly what the STL needs. So we have these ugly internal functions that do the actual work taking an allocator that we just don't provide to users because they're not in the standard. Okay, so same pattern here. If we're eligible for the optimization, now we need to worry about what if this is Constexpr land. So if def is constant evaluated. If we are not, then do the copy mem move. And then we've got now an early return of dest. So we don't need to worry about the rest of the code. We don't need an else. Okay, that seems fine. Okay. Okay, we're adding an ugly helper now. Why is this? This is all being, this is being added essentially because that wasn't present before. I think this is just, this looks like it's just for clarity. I don't see any centralization here. Maybe this will be called by vector. I have no concerns about having this unchecked algorithm being added without a clear use elsewhere. It seems fine. We often have an unchecked version that doesn't do all this unwrapping stuff. Okay, so new function template class, input iterator, class no throw forward iterator. Constexpr 20 dynamic, return the no throw forward it, underscore uninitialized copy unchecked. Edit first, constant last, no throw forward dest. Copy first last to raw dest dot dot dot. Okay. If Constexpr we're eligible for the really trivial optimization and we're not constant evaluated, then just return copy mem move. Okay. Otherwise, create the back out. Try to in-place back everything. Release and return. Okay, that looks good. So this is all being moved up. Got to pay attention to the type surgery here. So previously, we asked putter copycat, what's the declared type of uFirst, which is the unchecked iterator. Now we're passing the unchecked iterator to uninitialized copy unchecked. So querying init is the correct type. That's good. Whenever code is being moved but also being transformed, we need to make sure that the semantics are being unchanged. Same with udest. That's now the no throw forward it. Okay. Here we were updating udest, but then just returning it. Here we directly return, so that's fine. Uninitialized backout, decal type udest is now no throw forward it. Yep. We looped, okay. Dest is now udest. Yep. Okay, so that all looks good. I don't think we need to worry about moving these things. I know in the ranges algorithm we sometimes do. We certainly, especially for non-ranges code, I think that's fine. Plus they're const. This one's const, so that's fine. Okay, uninitialized move, Constexpr we're trying dynamic. If const evaluated, if const evaluated is available, then if we're not, early return, okay. Initialize fill-in, Constexpr we're trying dynamic. Same pattern, got the return there. These are now being fused into else if Constexpr, okay. Early return. Okay, that looks good. Getting to the end. Uninitialized value construct in, Constexpr returning dynamic. We're eligible for the optimization. If we're not constant evaluated, end if, okay, early return. That looks good. Implementing my erase remove. Because interesting, the ones in these are now Constexpr. I didn't actually realize they got Constexprized in the standard. Let's go check, see if this will load. So this is in containers, sequence, vector, erasure. They're Constexpr, yay! Okay, so that's why these helpers need to be Constexpr, great. Let's go back here. So this is Constexpr 20 dynamic. The container size type. Detach the comments so it doesn't wrap. Awesome. Yep, and it's just sort of free. It just works because the algorithm has already been Constexprized. Erase will be, so that's all great. Again, detach comment. Awesome. We've in previous code reviews explained how to detach comments. This is great. Awesome. Then, oh, this one's not being Constexpr 20 dynamic. It's just detaching the comment for consistency with the other ones. Erase node if is only used by the map-like containers that need to directly implement this rather than having the member remove if being called for the list family and the vector string deck family that call the erase remove idiom. So these should not be marked as Constexpr 20 dynamic because fortunately Constexpr map is not a thing, and maybe it will stay that way for CS+23. But I really like the consistency improvement here, so that's awesome. Thanks, let's go. And that's it for this header. Okay, so that looks good. So the biggest concern was the ABI mismatch for the mix and match issue for Orphan Me. Really, really easy to miss. And honestly, if we just didn't notice it here, we would probably get away with it. In practice, it seems like the mixing and matching member functions almost never happens because the linker just consistently picks stuff. But it is a theoretical concern. And the ODR scares us so much that being really strict about it is good. The rest were just like cosmetic issues about, maybe define these within the class definition. And the issue that we originally talked about in the other file that Mia noticed. Yeah, that looks good. So yeah, this PR looks good. I think I'm willing I would be willing to approve his suggestions except for that rename. So I will request changes here. Okay, so that looks good. Okay, got all my comments. Yeah, I really think that one's missing. Okay, that looks good. And I will deassign myself. Oh, I wasn't even assigned. Awesome. Okay, any questions at the end of this hour and a half code review?
Go, Cameron.
Yeah, so this is a great code review. Thank you, Stefan. You mentioned at the beginning that this was kind of an interesting PR because you depend on so much of the compiler internal and like compilers implementing the feature that you actually need to make it work. Was there any kind of growing pains that you experienced along this way, especially now that you're in the open source world?
I think that, and I think Mia understands the pains that we've been going through more. It seems that the main issue is when a fix is released, having to wait for the VS preview to be released, which is often a lag time of a couple months at worst. And even ideally, it's like a month if something is checked in like right before we snap the internal Prodigy branch for release. Sort of dealing with that delay has been the biggest headache. Aside from that, not massively so. The fact that we can at least consume the preview rapidly is good. If we had to wait for the released compiler, that would be an agonizing, quarter-long wait. But with the preview, we've been able to digest fixes pretty quickly, and we haven't been blocked too much. I think the biggest pain has been in like the header units test, where we've had so many workarounds for issues. Where we have a test that wants to proceed. With the Constexpr stuff, the issues have been blocking, which have been in some sense less painful because we just refrain from doing work until the compiler is available. And in some cases, having clang work is good because if we can proceed with one compiler, that makes our lives so much easier. It's when no compilers work and we're completely blocked from progress that is more of an issue. Is that sort of an accurate summary, Mia?
Yeah, I'd say so. I think that a big part of like this struggle here was one, there have been compiler bugs, and prior to working on this particular feature, I always just was like, oh, if I'm probably wrong. The compiler's probably I probably misunderstand something. So it takes a little bit of practice for me to like go back and read the standards to understand that there is a bug. And then there's always, once we discover a compiler bug that might potentially be blocking, there's always that toss up of like, well, should I try and implement the pieces that I can to see if I can uncover more compiler bugs, or it's like, or am I just going to spin my wheels and I should spend my time like looking at something else? And then if, once we do get that preview, we come upon something else that delays us even further. So I actually really applaud Misco here for like, I've kind of been reporting the bugs and poking around at stuff, but for the most part, I'm leaving Constexpr containers alone until we get preview 3. But he's still kind of like doing as much as he can to see if he needs to, report any other bugs and get those kind of unearthed earlier rather than later, which is super, super helpful. But I think this is just a fun feature that exercises some very new things.
Yeah, and having the sort of the different interpretations between Clang and MSVC, where the specific paths needed or taken to reach a function determines whether it can even be allowed. That's been sort of new. Previously, we've generally had MSVC and Clang both, implementing the standard, but they haven't required like different techniques. And in general, we can just use the same code for both of them. So that's been an interesting twist, but it's been sort of within the realm of what we can handle. If anything, although the Clang devs are absolutely awesome at how quickly they fix things, the fact that we consume Clang through the VS installer, and then because that only picks up the latest releases, which are approximately, I think, 6 months, It's actually Clang that we have to wait the longest for a new fixed build to be available, at least by default. We do have options for if something is fixed in like a point release, we can, in theory, detect that specific version of Clang and then light it up, light up the feature in the STL even before it becomes available through VS. So far, we haven't done that, but that does remain something we could do. So far, we haven't needed to just because the sort of 6-month release has been fast enough. We've always been, blocked on other things, or the feature doesn't even become available. And then the fix like Clang 11 comes out, and we're like, oh, okay, now we can use it. But as we're trying to get everything, CS+20 done in time, early in 2021. Sort of the iteration time or the latency for these new compiler shipping is more of a concern. So we may have to do things like that in the future.
Yeah, very cool. This is very cool stuff, though.
Awesome.
I mean, despite the compiler bugs, this is a pretty neat feature to come to C++.
Mm-hmm. I'm sort of excited to see what people will use it for, especially like Constexpr string. Like, what sort of amazing things will they do with the feature? Yeah, I never thought Constexpr would be used so extensively. It's like, oh, okay, yeah, we can avoid some template metaprogramming, but it's not like a massive world-changing thing. And then they started Constexprizing the algorithms, and I noticed, wow, we can do like a Constexpr sort. I can like sort a lookup table. This is pretty cool. And I can't even imagine what people are going to do with strings or vectors, because being able to have the flexible length sequence is very powerful.
Yeah, absolutely.
Okay, thank you.
Okay.
I am going to go ahead and stop the recording and transcription, and this video review will be posted publicly at some future date.
See you, future people.